the chemistry of carbon is not a particularly good indicator for the chemistry of the other elements in group 14. There are assumptions, or any assumptions, that the chemistry of the other group 14 elements resembles carbon are, mistaken. Now, why is that? Why is the chemistry of carbon unrepresentative of the rest of group 14? Well, essentially, it's got to do, quite again, with this size argument. Now, what does it take to form efficient multiple bonds? If you're going to have multiple bonds being formed, of course, the sigma bonds are formed by our s orbitals, or if you like, sp3 hybridized orbitals, overlapping along the molecular axis. If you're going to have a multiple bond, multiple bonds are formed when p orbitals overlap to form molecular pi bonds. And these p orbitals, of course, point straight up from your atoms. And so your atoms actually have to be really quite close together before the overlap of p orbitals to form pi molecular bonds is going to be significant. The earlier elements in a group are much more likely to form multiple bonds than the later elements. So the structure of carbon dioxide is a multiply bonded structure, whereas the structure of silicon dioxide is not a multiply bonded structure. Silicon atoms are too large for the overlap of p orbitals. SiO2 is extremely important. Now, SiO2 to most of us is sand. SiO2, which is an infinite network of silicon atoms bridged by oxygen atoms to other silicon atoms. So at the end of these bonds here, there are other silicon atoms, and those silicon atoms are also 4 coordinate, and they have 4 oxygen groups attached to them, and therefore you build up an infinite lattice which has these tetrahedral silicon centers in it. Now, if we take one of these species in isolation, that of course is formally an SiO4- ion. And that SiO4- ion doesn't necessarily have to share its oxygens with other silicon centers. It can share its oxygen atoms with other ions, like, for example, aluminium or calcium. If it shares it with aluminium, then we get aluminosilicates, which are really important compounds and form clays and things like that. There's also calcium silicates, which are important minerals. So you can get other elements in there. Silicones are polymeric materials with alkyl groups on silicon and bridging oxygens. They're the things that are used in things like bathroom sealant, that are used in things like lubricants. In order to be able to grow very large single crystals of silicon, you have to have very high purity silicon. How do you do that? How do you ensure that your silicon is very pure? You can make silicon fairly easily. If you take sand and you heat it with carbon in the form of, for example, coke, to very high temperatures, then you can isolate elemental silicon and you get carbon monoxide coming off. The problem with that method is that silica, sand, cannot be purified. You can't recrystallize this material very easily at all. Very difficult to do. And then silicon is again a very high melting material. You can't really purify silicon very easily. You need an easy chemistry, industrial method for purification of your silicon. So it might seem a little bit backward to you, but what you actually do is you then treat your silicon, your crude silicon that comes out of this process, with chlorine. And when you treat it with chlorine, what you get, the silicon is in group 14, favours a 4+4 oxidation state, you get silicon tetrachloride. So the silicon is oxidized by chlorine to give us silicon tetrachloride. Silicon tetrachloride has a boiling point of, I think it's around 45, 50, 60 degrees centigrade. It's a liquid which can be distilled. And if you have a liquid which can be distilled, you can distill it, and you can therefore purify it. So you can purify your silicon in the form of the silicon tetrachloride. And once you distill that and have a pure sample, you can then reduce it using elemental hydrogen back down to silicon. And this time, of course, our byproduct is hydrogen chloride. That byproduct is again a volatile gas, is lost. And what we're left with after a distillation of this is pure silicon.